Hello, grade 8. As we said, we will start with chapter 9 from this book, okay, which is actually about quadratic functions. Now, in this chapter, we will actually speak about, the graphing of the quadratic functions and study the properties of graphs for quadratic functions. Then we may solve quadratic equations by factoring, by finding square roots, by using the complex numbers, and by, it depends on the quadratic formula, and find the discriminant and decide if it has a solution, if the quadratic equation has a solution or not. And then we will solve system of quadratic and, and linear equations. And maybe at the end of the chapter, we will go and look for some models of, quadratic functions and linear functions and exponential functions, and how to distinguish between them, or how to recognize which function is actually we are talking about. Now, let's start with the first lesson from this chapter, which is quadratic graphs or quadratic function graphs and their properties. Now, I just want you to remember with me when we spoke about polynomials in chapter 8, we say a quadratic polynomial is actually a polynomial that has a maximum degree of 2. So when the exponent, the maximum degree exponent is 2, we are talking about a quadratic polynomial. If it's written in this standard where you have y and x, where you have two variables, and actually you will write one of the variables y equals, and a relationship that is connected with the other variable, or something happened to the other variable. So actually we are talking about a function. So what's a function? Before we start, what do you know about functions? Actually, miss, and what's the difference between functions and equations? Now, let's say that we are talking about two sides of one coin, okay? Now, but for sure that we will use functions for something, and we will use equations for other thing. Now, I want to tell you something that, a function is a relationship between two variables. One of them is independent variable, which is mostly x. Okay, it has its own character and it's independent, and the other variable, it is a dependent variable which depends on x. Yani it's affected by x. If I change x, y will be changed. Okay, now why do we use function? Actually, I need function to graph. I cannot ask you to graph equation, or you cannot be asked to graph equations, okay? Because if you want to graph, you have to set table. You want more than value of x, which I call them all together the domain, and you want more than value of y, which I call them values of y's, the range. So now in equations, you actually find, or you solve, you need equations to solve. Okay, in equations you will be asked to solve this equation, to find the values of x, if it was one value or two value or none, but at least you know that you have to find values, okay, that is connected with the only y that exists. Okay, now while in function, no, you have more than x, and when you substitute it, you will have more than y, so you will have a domain and range. You will point them, okay, or locate them in the x y coordinate to find out the graph and to define this graph belongs to which kind of function. Now, as I said, I will repeat it again, in quadratic functions, actually it has a standard form. We say a standard form, it's a general form for the quadratic function. It's a general form. You cannot find a quadratic function with this form where it shouldn't be, it mustn't be 0. Why is that? Because as you can see here, if a equals to 0, x squared will be gone. So, and you will have y equals bx plus c, which is linear function and not quadratic function. So, you can see that the main, let's say, character of the quadratic function is gone, whereas x is actually the maximum degree of this function. It must be 2. Or it must be quadratic. So it mustn't be, or it shouldn't be 0. You cannot put a with 0, but you can, of course, a could be 1, could be negative, could be positive. Okay. Now, and C and A and B, all of them are numbers. We call them constant, and if they are connected with variables like A, which is connected with x squared, and B, which is connected with x, I call them coefficients. Okay, and C, I call it constant since it's alone, there is no variable connected to it. Now, let's talk again about the graph of the parabola. How is the graph of the parabola looks like? As you can see here, if you look at xy coordinates and you see a graph that looks like U shape, you will know immediately that we are talking about a quadratic function graphs or quadratic graphs, which I call it parabolas, okay, or parabola. Now here, as you can see here, it has only two shape. Okay, one of them is while U is, or the parabola, looking up, and the other one is while the parabola looking downward. Okay, now this is the only two shapes. You cannot tell me that it's looking to the right side or left side. No, miss. It must it actually, this is another function. Okay. And actually it's a function that connected where x is the dependent variable. And anyway, I just want you to know that if the if you look at the graph at the xy coordinate and see a U-shaped graph, you will know immediately that you are talking about parabolas, or you are talking about quadratic functions. Now, actually, if you look here, there is a point. I mean, when I say point, I mean there is an x coordinate and y coordinate connected with each other. I call them vertex. Okay, a point in which the curve, as you can see here, changes its direction. As you can see here, if you look, the curve was going down. Okay, the curve for the U shape, and then at a point it just start looking up. Okay, or moving up. So at the point of converting from downing to looking up, or from looking up to looking down, I call it the vertex. I can tell you that again, a vertex, it's a point. Okay, so it has a coordinate of x and y. If I ask you actually to find the vertex, I'm asking you to write a point for me, okay, or to write a point of x and y coordinates. Now, let's say that vertex could you can let's say describe it by saying that the vertex, it has a minimum value or maximum value. Vertex could be minimum if and only if the parabola looks up, okay, or you can say like this parabola while it's looking up. So we can say that the vertex here has or its minimum. Okay, and the vertex could be maximum. We can say about it maximum vertex if the parabola looks down. Now, how can you know that from the function itself? Actually, if a, which is the coefficient of x squared, is negative, so we are talking about a parabola that looking down, and we are talking about maximum vertex. And if a, which is the coefficient of x squared, is more than 0, it means it's positive. So we are talking about a parabola that is looking upward and its minimum vertex. Now, in problem another, or let's, before we speak about the width of the parabolas, I want to define another character of the parabolas, which is the axis of symmetry. Axis of symmetry is actually an imaginary line, as you can see here, which divides the parabola or the quadratic function into two identical shapes. Okay, they are identical. It means that if you put a mirror instead of the axis of symmetry, you will look at the same shape or the same curve. Okay, now I call it axis of symmetry since you can see that there is a symmetry around it. Okay, it means there are two identical shapes. It's vertical. Okay, it cannot be horizontal at all. It's vertical, and I want to tell you something very important. It's passing through the vertex. Okay, so it's passing through the vertex. So since it's vertical, so the equation for vertical line, as we have said before, it's x equal something, right? It's x equal something. And I will tell you another thing actually. It's x equal the x coordinate of the vertex. Since, as you can see here, it passes through the vertex. So when I say x equal, and I give a constant, which is here 0, when I say x equals 0, first of all, this is the axis of symmetry equation, x equals 0. And second, this is the x coordinate of the vertex point. Okay? Now, when actually in this situation, especially in this situation, I call this quadratic function parent quadratic function. What's parent quadratic function? In which b and x equal 0, okay, and you have only and the vertex of it will be 0, 0. Okay, so the vertex of it will be 0, 0, and where b and c equals to 0. Now, I was going to tell you about the width of the parabolas, which we will discuss it more in problem 2 in the book, in the first lesson. Now, the parabola is wider than the graph of y equals x to the power 2. If, look here, it will look wider than this graph if the absolute value of a, because actually it's just the sign of the coefficient a, it just tells you if it's looking upward or downward. Okay, now, but if the absolute value is less than 1 and of course more than 0, so you are talking about a fraction, because it cannot be 0. If it's 0, so we don't have a quadratic function, we have linear function. But if the quadratic or the absolute value of a, it's less than 1 and more than 0, so it's actually a fraction. The parabola will be wider, or the width of the parabola will be more than a parabola that its coefficient of x squared, which is a, is more than 1. So as you can see, as the coefficient or the absolute value of the coefficient increase, the width of the parabola decrease. And we will discuss that more in the book. Okay? Now, As I said, that there is axis of symmetry equation. How to find it? We will find it in the second lesson, at the beginning of the second lesson, and you will find out that you will reach a point in which the axis of symmetry equation equals negative b over 2a. Don't forget the sign negative, because actually it's it's original, يعني it's from